Here in Bitnoff, Lab 8. In this lab right here, we're doing factory simulation. I'm gonna just go ahead and run through my variables right quick. Then we're gonna get down to the void setup loop, and then we're gonna get down to our void loop. All right. So basically, right here, what I got my button right here. It's pretty much set on pin 2. I got LEDs in an array right here, and I got my motor on pin 11. It's also within that array as well. I got my light sensor set on pin A1. My temp sensor is set on pin A0. My warehouse counter, I set it basically at 0 because that's where I wanted to start at. And I got my assembly counter is set at 0. This particular counter right here is only going to count up to 2 and then reset itself back to 0. And I got my button press right here set at 0. My pin count right here is the amount of pins that's in the array. And I got a process wait time of 4 seconds. I got a second process wait time at 7 seconds and a serial wait at 1050 and a debounce for my button set at 150. All right. And now we're just gonna go ahead and get to the void setup portion of this lab. I got a for loop right here for my array. I got my serial begin at 9600. It basically establishes communication between the computer and the microcontroller. Speed at 9600 baud. I got my button set as an output, not an output, but an input. Temperature sensor as an input. LED light sensor set as an input. What is wrong? And my motor is set as an output, and my LED pins is set as an output as well in an array. And we're gonna get down here to the void loop. Basically, in my void loop here, I established a button state. Basically holds the state of the button, and right here I'm just saying button state equals digital read high, read the button. I got my serial print. It's gonna print this within the on the serial window screen, and then it's gonna actually print the state of the button, and that state of the button is either 0 or 1. The 0 indicating that the button is low. 1 is indicating that the button is high and it has been pressed. And I got the serial wait time here. Excuse me, I'm sorry about that. And basically for my button statement, I got an if statement here. It's basically stating that if the button state is high, then read the button state, delay the debounce of the button, and we're gonna write LED pin 1, which is a red LED high, and the motor high. And both of those right there is gonna come on for roughly about 4 seconds, and then they're gonna go off, the motor and the red LED. And then it's gonna write the green LED high, which is on, and it's gonna be on roughly about 7 seconds. And my process wait time here is 7 seconds. And then after those 7 seconds, it's gonna go off, and then it's gonna print process 1. All right. And we're gonna go down here to my second process here, which is basically gonna be based on the light, the photo resistor. Here we're gonna analog read the light sensor. It's gonna print this statement within this parentheses, and it's gonna actually print the actual value of the light state. Then it's gonna wait to print it for 10. It's gonna wait for roughly about a second to print that statement, that value of the light state. And here's the statement right here saying that if the light state is greater than 210, then turn the red LED high and the motor high. So basically both the motor and the red LED is going to be high here, and it's gonna be high for 4 seconds. And after that 4 seconds, both the motor and the red LED will go off, and it would turn my third green LED on for 7 seconds, and it's gonna wait, and then it's gonna go. The green LED is gonna go off, and it's gonna print process 2. And my third process, assembly process here, got a temperature sensor on it, and basically temperature state there. It's going to read the temperature sensor. Right here, I got a map of the temperature. Basically right here, I'm just trying to map it to the ambient temperature of the area that I'm currently in. And it's going to print the temp sensor state here. And it's going to print the actual temperature, ambient temperature here. Then it's going to wait to print that. Then we're going to go over here. It says if the temperature state is greater or equal to 73 degrees, then I would like for you to turn the red LED on, the motor on, and I would like for you to wait 4 seconds. Then after that 4 seconds, I want you to add 1 to this counter. And after you have done that, I would like for you to turn the motor off, the red LED off, and the motor off. And after that, I would like for you to turn the green LED on, and I would like for you to wait 7 seconds, turn the green LED off, serial print, the count is equal to whatever number right here, either 1 or 2 or 0. Because this particular counter right here will reset once it equals 2. Then I want you to print assembly. Then I want you to serial weight that. And then down here, if my counter is greater or equal to 2, I would just like for you to reset that counter. And while you reset that counter, I want you to add 1 to my warehouse counter. And this counter right here is particularly keeps track of the inventory within the warehouse. And here is going to say, I want you to write warehouse counter is equal to, and the actual number of whole products or finished products that you have within the warehouse. So basically this counter here is just keeping track of the warehouse inventory. So down here, and I'm saying that if this counter right here is equal to 0 or reset itself back to 0, I want you to turn 2 green LED lights on, wait 4 seconds, then turn those green LEDs off. And those 2 LEDs, those 2 green LEDs is basically indicating that we have a finished product within the warehouse. Now, I'm gonna go ahead and turn my serial monitor back on here. And we're gonna get to the breadboard and the actual processor here. And go ahead and reset that for you. And right here, this is my current state, temperature 71 degrees, button state 0, light state 98, temperature 71, da-da-da. Now, we're gonna go ahead and get this started for you. So, here's my little setup. Microcontroller here is gonna communicate with this. And we got 1, 2, 3, 4, 5, 6 LEDs here, 7, 8 LEDs here. And these are all the indications that the motor has started, stopped, started, stopped, started, stopped. And we got a photoresistor here, which is gonna indicate an inspection stage. A button is going to indicate a press stage, and temperature sensor is going to indicate curing stage in my particular process. And we got a motor over here that's representing the transportation stage. So when I press this button, this light right here is going to come on for this light is going to come on for 4 seconds. This motor is going to come on for 4 seconds. And after those 4 seconds, it's going to print process 1 there. And light sensor This LED here is gonna come on. That motor is gonna come on for 4 seconds. After 4 seconds, this green LED is gonna light up for 7 seconds. And it's gonna go off after 7 seconds. And then once the temperature is greater than 73 degrees, this red light is gonna come on, and this blue LED is gonna come on for 4 seconds. And then if the counter is equal to 2 or reset itself back to 0, these two green LEDs right here will come on, indicating that we have a finished product within the warehouse. So we're just gonna go ahead and get this started by pressing this button. This light is gonna come on, this motor is gonna come on. Motor come on, light come on. Button state is equal to 1. Green light is on. We're gonna wait about 7 seconds. It's gonna go off. Now, I'm gonna go ahead and grab my flashlight here to activate this photo resistor. And over here, we're gonna see the light state change from 100 or 102 to whatever the reading of it is. So here we go. Light 767, red light on, fan running, green light come on after 4 seconds. Then go off. Wow. And it also printed process 2. I don't know what that right there is about. I figured it out after this. I'm gonna continue to move on through this process. So now we're gonna get the temperature sensor here. We're gonna get that above or equal to 73 degrees so we can turn this red light on. All right, so here we go. We're looking over here for this temperature to equal 70, there we go. Now I gotta cool it off. All right. Right here we got our count is 1 and assembly. And we're gonna go back through the process again, starting with the button, the photo sensor, and the temp sensor. And everything is gonna work accordingly. We're gonna see a count after this temp sensor right here. After this blue light goes off, we're gonna see a count of 2. It's gonna reset itself, and these 2 green LEDs right here will come on. So I'm gonna just go back through the whole process again, starting with the button. Red light on, motor running. Motor stop, red light goes off, green light come on. Green light on for 7 seconds. Goes off. Light sensor. Light on, motor on, 4 seconds. Green light on for 7 seconds. Goes off. Now we're gonna get to the temperature sensor here. We're looking for a temperature of 73 or greater than 73 there. 73. Red light on is running. And we want to pay attention to this blue light and these right here in warehouse here. Warehouse counter equals 1 here. The green light did come on. And we're gonna simulate this process here to cut down on time here with my video. We're gonna turn this light sensor on, this temperature sensor on again. We're gonna do that 2 times. Let's see this come on. We're gonna see the warehouse counter goes up to 2, and then we're gonna see it go up to 3 after this is done roughly about 4 times. There we go. That's 1. We're gonna see our counter up here indicate 1. Our counter equals 1 there. We're gonna do the temperature again. Temperature 74. Counter should be 2. These green LEDs are gonna come on. We're gonna see a warehouse count of 2 here. Count of 2, warehouse 2, green lights on. And we're gonna do this 2 more times, and this basically gonna end the video. Okay, we don't have to do it because it's still reading the temp sensor. You're gonna see the count, the assembly count at 1. Assembly count is 1. And we're gonna do this temperature. We're gonna increase the temperature again, so this warehouse green lights can come on, and the warehouse counter be 3, should be. Blue light. Green lights come on, okay. Counter equal to 3. And as you can see, this process worked just fine for this particular application. My name is Henry Benoff, Computer Programming, Lab 8. Thank you for viewing this video. Thank you. Bye-bye.